Picture the astronaut. Go on, picture it. You already have the image in your head, don't you? Suit, boots, flag, maybe a little bounce in the step like it's the moon all over again. Big triumphant moment. Someone's grandkids are going to learn the name in school. Forget that image. Burn it down. Because that's not what landing on Europa looks like. That's not what it feels like. And the difference between those two things is the entire point of what I want to tell you today. Here's the thing nobody says out loud. The landing isn't the dangerous part. Everybody worries about the landing. The fuel, the trajectory, the 7 minutes of terror, that's the part Hollywood knows how to film. But the real danger, the one that actually changes a person, starts after the boots touch the ice. Because the ground under those boots isn't really ground. It's a shell, a crust. And underneath that crust, not symbolically, not someday, but right now, while you're reading this, there's an ocean. A whole ocean, dark and silent, wrapped around a rocky core like the yolk of an egg you're not allowed to crack. So let's start there. Let's start with the ice, because the ice is lying to you. You'd look at Europa's surface and think, solid world, like any other moon. Cratered, maybe a bit smooth in places, kind of pretty even, crisscrossed with these reddish-brown streaks that look like cracks in a china plate. And they are cracks, that's not a metaphor. But here's the part that should stop you cold. That ice isn't just floating on rock, it's floating on liquid water. An ocean estimated to hold more than twice the volume of every ocean on Earth combined. 2 Earths worth of ocean, hidden under a shell of ice that might be 10, 20, maybe 30 kilometers thick in places. Nobody's totally sure. And that uncertainty alone should make you nervous. So when I said the astronaut is standing on solid ground, I lied to you on purpose, just so you'd feel what everybody assumes when they hear moon landing. The truth is, they're standing on a lid over an abyss. And that changes everything about what walking even means out there. Now, why is there liquid water at all? This is Jupiter's moon. It should be a frozen brick, end of story. Except Jupiter itself won't leave it alone. Jupiter's gravity is enormous, and Europa doesn't orbit it in a perfect circle. Its orbit is slightly stretched, slightly eccentric, tugged on by the other big moons nearby. That means Jupiter's gravitational pull on Europa isn't constant. It squeezes, releases, squeezes again, like you're kneading a stress ball over and over for 4.5 billion years. That squeezing generates heat, real physical friction inside the moon's interior, the same kind of heat you'd feel bending a paperclip back and forth until it gets warm in your fingers, except here it's happening on a planetary scale, deep inside rock and ice, driven by gravity instead of your hand. And that heat is enough, just barely enough, to keep an entire ocean liquid underneath a shell of ice in permanent darkness, no sunlight reaching down there at all. Which means Europa isn't just an ice ball. It's one of the best candidates we have, maybe the best candidate for finding life somewhere else in the solar system. Not little green men, microbes, something metabolizing in the dark, the way we find life clustered around hydrothermal vents at the bottom of Earth's oceans, thriving without a single photon of sunlight, running entirely on chemistry instead of light. Now hold that thought, because that's exactly where the radiation problem shows up and ruins the mood. Jupiter isn't just a big, pretty planet with a red spot. It's got a magnetic field that's monstrous, by far the strongest of any planet in the solar system. And that field traps charged particles, electrons and ions, whipping them around at close to the speed of light. Europa sits right inside that radiation belt. Not near it, inside it. The radiation levels at Europa's surface are 45, and I want you to actually sit with this number. No pence, thousands of times higher than what a human could survive unshielded on Earth. An astronaut standing on that ice without serious shielding could get a lethal dose in a matter of hours, not years, hours. So here's the mechanism, plainly, no metaphors yet. Radiation at that intensity is just particles slamming into matter, and your body is matter. Those particles tear through cells, they rip through DNA strands, snap the backbone of the molecule, sometimes in ways your cells can repair, sometimes in ways they can't. Enough of that, fast enough, and your body just can't keep up with the damage. Organs fail, tissue breaks down. It's not dramatic in the movie sense, it's just physics doing what physics does, indifferent to the fact that you flew 400 million miles to get there. You shield against it, obviously. Thick hulls, water jackets, clever engineering. But shielding buys you time, not immunity. Every hour on that surface is a countdown, and the astronaut knows it. That's not a detail in the mission plan. That's the entire psychological weather system they're living inside. Now put those two facts next to each other for a second. Underneath the ice, maybe life, hidden, ancient, untouched. On top of the ice, a radiation storm violent enough to cook a human being if the shielding fails. That's the paradox nobody puts on the recruitment poster. You go to Europa because it might hold life, and the moment you get there, the environment is actively trying to kill you for being alive. Let's go a layer deeper, though, because the radiation isn't even the strangest part. The strangest part is what standing there does to a person's mind. Think about where this astronaut actually is. Jupiter fills half the sky, not a dot, not a disk, an actual wall of banded cloud and storm hanging over the horizon, silent, motionless in a way that feels wrong for something so big. There's no wind on Europa because there's essentially no atmosphere to make wind, so nothing moves, no dust blowing, no sound at all, because sound needs air to carry it, and there's barely any air to carry anything. You could drop something right next to yourself and never hear it land. We already know from isolation experiments here on Earth, polar stations, submarine crews, people sealed off from ordinary human contact, that extreme isolation does something to the mind. It's not just loneliness, it's a kind of drift where your sense of scale, your sense of significance starts to reorganize itself. Now take that effect and multiply it by the fact that you're standing on a frozen shell over an ocean you can't see, under a planet you can't ignore, further from home than any human has ever physically been. Nobody's run that experiment. We genuinely don't know what 400 and some days of that does to a person's mind, because it's never happened. That's not me being dramatic, that's me being honest. It's an open question, and I don't like pretending it isn't. Here's the part that gets even stranger, though. The part where the mission's whole purpose turns back and points at itself. To keep the astronaut alive, you shield them from radiation, from cold, from vacuum. Standard stuff, that's what a spacesuit is for. But to protect Europa, you have to shield it from the astronaut. Every human being is basically a walking colony of microbes. Skin, gut, breath, all of it carrying life from Earth. If even a trace of that gets through a crack in the ice into that hidden ocean, you've potentially contaminated the one place in the solar system where we might find life that evolved completely independent of us. You'd never know if what you found down there was truly alien or just something we brought with us and forgot we were carrying. So the mission design has this built-in contradiction. Protect the human from the environment. Protect the environment from the human. Every shield, every sterilization protocol, every layer of engineering is fighting on two fronts at once, keeping something out and also keeping something in. That's not a footnote. That's the actual core tension of the entire endeavor. Now, Sita, what does all of this actually do to the astronaut? Because that's the real question, isn't it? Not can they survive, but who are they when they get back, if they get back? Here's what I think happens. Somewhere in those months on the ice, staring at Jupiter, knowing there's an ocean under their boots that might hold something alive, knowing every breath they take is a threat to that same ocean, the categories they use to sort the universe start to blur. Alive, not alive, home, elsewhere. Those words work fine on Earth, where the line between living thing and rock is usually pretty obvious. But standing on Europa, where the most promising sign of life in the solar system is sealed behind 20 kilometers of ice you're forbidden to disturb, alive stops being a category you can just point at. It becomes a question you carry around in your chest for the rest of your life. That's what I mean when I say they'd never come back the same. It's not just muscle atrophy from low gravity or radiation damage that shows up on a scan years later, although both of those are real, both of those matter. It's that they've stood somewhere the categories broke down, and once your categories break down once, they don't ever fully snap back into place. You start seeing that same fragility everywhere, in every ocean, every ice sheet, every dark place we haven't looked yet. And look, I want to be straight with you about what we don't know, because I think pretending otherwise is a kind of dishonesty I don't want any part of. We don't know if there's anything alive in that ocean. Not a hint, not a hunch confirmed, an open question, genuinely open. We don't know if the chemistry down there, whatever's dissolved in that water, whatever's leaching out of the rocky core, can actually support life the way vent ecosystems do on Earth. It's a good guess, a strong hypothesis, but a hypothesis is not a discovery, and I won't dress it up as one. And we don't know, really don't know, what the psychological weight of that place does to a human mind over the time scale a real mission would require, because nobody has ever tried it. Not once. There's no data. There's no precedent. There's just the honest limit of what we currently understand standing right there in front of us, refusing to be rushed. That not knowing isn't a failure of the story. It's the most interesting part of it. So here's how I picture the ending. Not the triumphant flag moment, not the scripted line for the cameras back home. I picture the astronaut near the end of the mission doing something small, turning off their helmet light, just to see what real darkness looks like on another world. No city glow, no moonlight, nothing but Jupiter's faint reflected light on the ice and the absolute silence of a place with no wind to carry any sound at all. And in that moment, I think they'd realize something. The whole trip, everyone back home was looking up at Jupiter, up at the mission, up at the astronaut, like they were the point of the story. But the actual frontier, the real mystery, was never above their head. It was beneath their boots the entire time. Closer than any star they'd ever looked at, sealed, silent, untouched. And still, after all of it, completely unknown. That's the thing about places like Europa. They don't hand you an answer wrapped up neat at the end of the journey. What they hand you is a better question, a bigger one than you brought with you. And if you're honest, if you're paying attention, you walk away smaller, and the universe walks away bigger. And that trade is, I think, the best one science has ever offered anybody.